Hello everybody, welcome back to the channel. This is Michael, KE4EST. And today we have an Eico Model 488, as you can see right here. Electronic switch. Now what this is, it allows you, it's got two inputs and an output here. It allows you to, back in years ago, this came out in the early 60s, this particular one did, but they come out other brands and models before this, but this allows you to take two inputs and one output. To the old oscilloscopes only had one input, so this will give you a dual trace oscilloscope, and it only works up, as you can see, 2000. That's 2000 hertz. It's low frequency. It's good down in the the audio portion and stuff like that, and lower audio frequencies and whatever, but it's just really neat. I mean, this day and time, I don't need something like this, really, and you can get dual trace oscilloscopes pretty cheap, and 4-channel oscilloscopes, but it's still pretty neat device, and I've seen these before, and I've kind of always wanted one, and this one was sitting at a estate sale, and I was like, okay, looks pretty clean. Of course, the guy had it plugged up. I don't know what exactly it is, but when I turn it on, the little light comes on. So who knows? But like I've said before, I don't like to plug these things in until I go through them and check them and stuff, because you can burn out the transformer. If we have a shorted capacitor where it's leaking too bad. But anyway, but you can see here, it's you got your amplitude selection on each side here with your inputs, and of course, back then it was just twisted pair coming in, with no BNC jacks. Got one here, it's a little bit loose here, and so you'd feed your signal in here for one channel and the other channel in here, and you got your amplitude controls. I start to say that's a little backwards. I was reading this as going to this one, but this one, the writing here goes to this knob. It's underneath an amplitude 1, amplitude 2. And this is your positioning control, your frequency selector, and this sets your frequency range of what you're going to be feeding into it right here. And then this will be like, if you got it 10 to 100 hertz, then this here down here would be 10 hertz, and it comes on up going toward 100. This will be 100 hertz. This is on set for 50 to 400. Down here would be 50, and you're working your way up toward this end, be 400 hertz. On and off switch and your output. And for people who want to, you can't really see that. I'm trying to change the lighting just a little bit there. Well, you can see it a little bit, but serial number is 7031. It's stamped in there. Anyway, so I'm anxious to get this open. It's pretty good shape. There's something oversprayed here or spilled on it or something here. But you can see the case still is in really good shape with the hammer tone finish. So, and then on the back, of course, you're just going to have a power cord, and that's it. For something like this, I don't know what this is. Well, I know it's some kind of a duct tape, but I don't know why it's on there. If it was here to maybe wrap the cord up and taped it or what one time, but it's off of there now, which I was going to take it off anyway. Got some scuffing back here. And there's only 2 screws to take it out, or take it apart, and I've already took the screws out. So let's see if we can get this thing apart here. And yeah, let's see here. There it goes. Let me set this over here and get this cord. Oof, I can smell that smell. Yeah, I don't like that smell. There's the inside. Everything's pretty clean. But yeah, right off the bat here, I can smell. Let me see. Yeah, it's coming from this transformer, that smell is. right here, this power transformer. And see, that's what happens. Stuff's set around, these capacitors go, especially like the filter caps, and then you try to plug something in and they get real leaky. So let's hope this thing will still work okay. We don't have to leave it out of the case for a while and let that air out. That's real strong smell off of that. So let's hope it still works and puts out voltage like it's supposed to. All that. But we can look at the top here. Just trying to angle that a little different, but I think it'll be good enough here. Power transformer. And of course we got tubes here, and Eico, or the Electronic Instrument Company, or Eico for short. You know, they had kits, and then you could buy, you know, wired and tested. This one looks like somebody put together. From what everything I can see just right off the bat, and you can see somebody stuck a pencil and labeled, like, if you can see that. They've labeled or different, like where this goes. It says TB1. Terminal block maybe, or something 1. Not sure exactly what, without looking at the schematic or the builder's thing. I don't know what they're exactly, but anyway, one thing I see right off the bat too here, and I was just looking to see if all of them, yep, all original tubes. This here looks like a 12AU7, a 12AX7. Well, can't get the right angle. Let's just pull it out. Yep, 12AU7. Okay. So we got a couple 12AU7s here. This looks like a 6X5. Yep. So this would be your rectifier tube for your high voltage. One of these tubes here would probably be for oscillator. Then one would be to probably kind of like amplify the oscillations back and forth, because what it'll do is it'll oscillate back and forth between, probably like this is got 2 triodes in it, so it's probably, you know, oscillating back and forth and sending it over to this tube. And then these tubes here, I can see is 6AU6s, or EF94s. And so these would be your mixers. It would kind of act as a mixer. It would take your oscillator, it would go into this, and this would go into these for one channel and the other channel. These tubes there, well, it looks kind of dark. But anyway, and then to your output, and then you have your inputs would come in too on one of the grids and whatever. We'll find the schematic on it. This here's probably a choke. Yeah, 16X5. This here's a choke. Your filter capacitor can. This here be your oscillator section here. See, maybe turn it this way. You can see that we got a capacitor there, and then these 2 capacitors, then the capacitor here, and then these 2 capacitors. If we look, they'll probably be, yeah, this one is the same as this one, and this one. So there's these 6 here, these 3, and these 3 match up. So that when you're, you know, selecting your frequency, it matches both sides, so that, you know, for your oscillator. Okay, let's see what's the safest way to set this on. Let's look at the bottom here. Okay. Well, they liked orange, didn't they? Maybe that's what they sent in the kit, I don't know. But we got all orange point-to-point wiring here. And I see right off the bat, like, see this capacitor, it's already physically leaking something out. But, of course, I'm sure it's leaking by now electronically too, or electrically leaking too, so that'll have to go. These two paper foil have to go. These resistors here, this one and this one, this one, this one, them are all the Allen Bradley style resistors, so they're probably good. But if you get down here and you look down here, let's zoom in on that as I talk about it. Bring this. I hope you can see that. Sometimes I know on camera it's kind of hard to tell, but if you look at these two resistors here, how they kind of round off on the end. It's what they call, a lot of the guys call them roundies. Those definitely, well, I'll probably just replace them. But sometimes they can be good and be fine. And then sometimes they'll be off. But these are real common for these at this stage in its life. This thing being like 50-some, 60 years old. For these here to be off in value. Instead of being what they, are supposed to be. So, and even though it's got a 5% band, and some of them were designed a little bit better, like the 5% tolerance on these. Like the rest of this stuff is either 10 or 20%. Well, no, there's some up here above where you can I move the camera. There's some more 5% up here. There's 10%, and this one here's 20%. So, but definitely replace those. That. Clean up the. There's another thing too. If you're looking, see how somebody's wrote all these in pencil. You know what goes where, so I help them get it together properly. But all in all, pretty good here. I don't like how tight these wires here are, especially this line cord coming in here, and this line cord just hanging in midair here. This cause noise, from the line cord to get into it, especially something at this low frequency. And there's not a whole lot of filtering going on here. So I may take this and I redo this line cord and take this and put this and tuck it against the chassis here to cut down on noise. Other than that, this is a good candidate for restoring. I just hope this transformer's good. And I know it's not this big, this is not that big of a deal. It's like really, what would you want that for? Something to take. Okay, so it makes a single channel oscilloscope a dual channel, kind of, sort of. And it only works at really low frequencies, maximum 2K, 2000 hertz. But, it's just the neatness of it. I've seen these before, and I always wanted one, and I come across this, I'm like, I gotta have that. And the guy was like, I got it plugged in, all it does is a red light. I move some knobs, I don't see anything different, I don't know what it does. And I'm like, yeah, because you gotta hook some more equipment up to it to see it actually do something. But, so, I'll go through and check all the tubes out, and I hope they're all good. And they're all, every one of them, like I'll pull another one out. I'll grab one of these 686s, which is a Pentode EF94 686 Mullard, Great Britain. But you see it's got Eico right on there. Every one of them does. Even this 6X5, and I'm glad it's a GT version. Because they got a 6X5, it's just all metal, and I really like the glass ones, I think most people do. For nostalgia, see them light up. But even that, you can see there, it says Eico on it. Made in the USA for Eico by General Electric Company. And you can see that maybe barely. 6X5 GT. Or GT for glass tube instead of a metal, or as opposed to the metal. But anyway, I'll get all that checked out and change out some stuff and find a schematic, and We'll be right back. Okay, here I am. I am right in the middle of the restore here, and I thought you guys might want to see kind of what I've done so far. Maybe we'll go over the schematic. I've got the schematic now. So I've not done anything with this yet. Not decided how I'm gonna do that. They didn't quite leave me enough. They might be enough to go thread this up under here. Well, that's not as tight as I thought it was. Oh, that was tighter there. Anyhow, so what I'm doing right now, well, you can see right here I've got this capacitors. I'll bring the camera down just a little bit here. I've got these capacitors here. I looked in the monitor and see this toothbrush laying here. You know, I got to keep my teeth clean. I'm on camera. Of course, I'm using this for cleaning. Anyway, okay. These two capacitors here, which were these two here, I've replaced those. And this over here, which, if you remember, there was this electrolytic capacitor that was going from, let's see, it was going from here, and then it came out and it went around, where are you? No, I don't want to see that. I've got so much stuff here right now. It's always a mess when I'm going through all this stuff. Well, I don't see the exact capacitor. We'll use one of these for, you know, it's not one of these, it was electrolytic. It was that dry paper electrolytic, but it was setting in here, and the wire was going to here, and it come up here to ground. A ground lug that was up under here. And what I done is I took that off and I moved that down to here. Let's see if I can get where you can see that. I moved that down to here, and then just stuck a capacitor, the new capacitor right in there, just like that. And it was an 8 microfarad, and I went with a 10 microfarad. That should be okay. In this circuit, I've got the schematic, because that was the 8 there. Let's see. What have I done? Let's see. I'll go ahead and show you what I've done on top here. I've replaced, remember there was 2 mica capacitors, and then just a foam paper waxy was here. As you got 3 capacitors on each side, and these match up. Get it where I can kind of, you can see that, you know, this is the same, and then this one and this one, and then this one's the same, and then this one and this one. And this one and this one was a mica capacitor like this, but it was 1,000 picofarad or 0.001 microfarad. And it's rare for them to be, you know, bad usually. Well, I was checking one of them, and it was, no, it should be like, I say 0.001 or 1,000 picofarad. It was kind of closer to 1,200 picofarad, which is really pushing the 20%, and it probably would work, but you know, that was kind of far off. And I checked the other one, and it was even further off, and I thought, well, that's odd. And then when I put them on the capacitor tester to test them, they were testing bad. So I thought, well, that's interesting. So I don't know. And both of them, of course, they both probably come out of the same lot, you know, at the same time. So it might have been a bad run of them or something. These here, these 200 picofarad caps, they were showing, one was showing 216, which is fine, and checked out really good on the tester. The other one was showing 203 or something like that. It was really good, really close, and it showed really good on the tester, so I left those in. But I had to replace those, and of course I replaced the 5,000 picofarad or 0.005, and I replaced it with a 0.0047, which is, you know, a modern equivalent this day and time. I just got these tubes here removed so they wouldn't in my way, and I didn't bump them or anything. And I have tested the tubes. This 12AU7 here, one side of it's weak, which it really needs to be matched as close as it can be. It wasn't real weak, but it was borderline, and I hate that because it's an Eico, stamped on it Eico, but I'll change that out. I may swap them around, put the other one in here and put the Eico out here, because I think you can see that Eico on it. But so there's that. Let's pull the schematic over here. This is the schematic for the Eico Model 488 electronic switch. Probably can't read that on camera. 1964. 1964. Well, that's hard for me to read. Is that a 54? I'll have to look that up again. I think that's 64. Anyhow, I had another thing laying here somewhere. I'll look it up here in a minute. But anyhow, so going over this, you got your transformer here. You got your, and you can see this right here is, you know, your switch. You can see I'll just directly wire it in here. Your plug coming in through a switch to the primary, your transformer, and secondary. You got high voltage, and you got your, this is 6.3 volt to feed the filaments of the tubes. And yeah, these are 12AU7s, 12 volt filament, but 12AU7, 12AX7s, all those are designed so that you can run them off of, because the filament, these are, you know, they're 2 triodes in each tube. And the way they've got the filament strung inside, seriesed up, you can run 12 volts or you can run 6 volts. So what they chose to do here is run 6 volts to power these 12AU7s here. This is a type 47 bulb in here. You can see right in there. 6 volt bulb. Okay, so then here is high voltage. We've got the center tap grounded out, so we make a full wave rectifier. Your 6X5 here. And then you got voltage. Your B plus will be coming off of here. And it's nice to have a little voltage chart down here, and it says it should be 350 volts or thereabouts. Coming off of here, going through this capacitor here, and that's the one I've already replaced right here. And then you're going through your choke. That's on top of the chassis. And then you're coming down to your filter capacitor here. And then if you look over here, there's another filter capacitor here. These two are 20 microfarad at 450 volt. And of course that's feeding in your supply voltage. So your plate voltage comes up through a drop-in resistor to this divider here, to these plates of these triodes. So I said tubes, but this is one tube here. So you got one, it's hard to see what way somebody scanned this in, but V1A, V1B. So you got the voltage going there, and then over here you got that selector switch on the front selecting these capacitors. And you can see that on top of you select one, and these are tied together, so when you flip the switch, you're going to click. This is C1 and C4 selected. If I click it to the next notch, it's going down to C2 and C5, and click it as far as it'll go, because it's only got 3 positions. C3 and C6 will be in circuit. It's ganged, the switch is ganged together, but it ain't going to tie C6 and C3 together. They're just going to be, as I flip this switch here, it's going to bring those in. Okay. The plate voltage coming in here, say we'll start with this one, goes through this capacitor down in the grid of this tube here, or this triode here. And the same way on this one's opposite. We got voltage coming in here, going through is whichever capacitor you have selected, the grid of this one. So what we're going to have here is an oscillator, and the cathodes are grounded out here, so this is going to oscillate back and forth to make like a square wave. And that's how you get your dual traces on your screen. You have square wave, one this way, back and forth, 2 square waves. So you can get them trace. Say if this was a oscilloscope, now you've got, say, a square wave here, then you got a square wave over here, and you can have 2 traces. And then that's saying that every time it goes here, this is when this one, when it's this one's turn on, it's going to pulse. This one will pulse down here, and then this one will pulse, and this one will pulse. So we see we got this coupling capacitor, which is a blocking capacitor. In this case, it's blocking the DC going into the grid of this next tube here, which is another 1287. The pulse will get through, this capacitor and go into this tube, but the high voltage that we have set up over here won't. It'll block that high voltage. So the pulse will go through and turn this tube on. Then this one will go through and turn this tube on, back and forth. And you can see this tube and this 686 pentode here, the cathodes are tied together and they're going to ground through a resistor. Same thing down here, just mirrored of it on this side. See how this is input here and this input down here, these are set the same all the way to your output. So, but it's going through ground through a resistor here, which is going to pull it up above ground, and down here it says about 32 volts. So that's going to bias these tubes here and just have them setting at a level there's ready just to very easily be turned on. So when you have a pulse here, it's going to turn this tube on here, and when this tube turns on, and this is setting at 32 volts, it's going to pull that cathode up. It's going to shoot up, causing this tube here to shut off. Whatever you got on the input here is going to shut off, and you won't see it for that, as long as that square wave's there. Pulse, and then when it drops, then this will let this back in. And then the same way down here, just go back and forth. So that way one thing, then the other one, then one, then the other, but it'll go back and forth fast enough. If you get, going fast enough, your eyes and stuff ain't going to tell a difference, and you're going to see on your oscilloscope, you're going to look like 2 traces and 2 different waveforms going on. And then we come out through here. Here's our this is our position control on the front here. This R13 is right here, and they'll just move it up and down. This is going to the screen grid here, so that it's this one, they're tied back to B plus here through another resistor. So as you put more screen voltage this way and more screen voltage this way, it's going to cause that to shift up and down. Okay, and some bypass capacitors and the ground. There's that. We already talked about the other filter capacitor. And then these 2 plates here, off the plates here, you can see they're tied together, and then there's ground, there's output. And if you see that, you notice this is straight out. So the plate voltage is going to be right on this jack here. So you got to be careful if you've got some kind of oddball cheap oscilloscope that you want to test this with on a newer type oscilloscope. It says the voltage is, let's see here, pin 5 of V4. Let's do that one. 270 volts. And that could be a little higher than that with, say this was set for 115, you plug it in today's outlets and it's 120 to 125, that may be closer to 300 volts there. So you got to be careful with that for your front end of your scope. Like a lot of scopes will go up to 400 volts or so. Some of them maybe not, so check that. And be careful if you're working with that. You don't want to zap yourself. And if you're not sure and you don't want to do it or whatever, then just don't do it. You know, or you can put a blocking capacitor in there, which will really mess up your square wave. But if you just want to use it for testing and to say, I got this thing restored and well, I can see that it works. It's not exactly right, but it works, and then stick it on a shelf or whatever. But I just want to remind you of that, just because there's, you know, the 270 volts is right there. You stick your finger to it, you're going to feel it. And then it could possibly damage your scope, so be careful with that. So there's the schematic. So also you can see, let me bring this more in here. So this can here, I'm going to leave in there for aesthetics, for looks. Some people will go in and gut these out and take and put the capacitors up in there. You know, it's up to you, whatever you want to do. If you do that, make sure for sure that you put a note in here somewhere, a label, you know, back in here or something, or whatever. Let, you know, the next person comes along or something, or you come along in 40 years and you're getting older and senile and forgot that you stuffed this, or somebody just cut it out and throw it away, and you know, or whatever. And then some people take capacitors, even like these. They'll take these here and they'll carefully cut these in half, or they'll gut them out, you know, drill them out and put a new capacitor inside of it just to keep the same look of the old capacitor. Just if you do that, make sure you put a label on, hey, this has been done to this. It's, you know, because if something happens, say even you probably think, well, if it's 50 or 60 years from now, they probably need to replace it again anyway. But it might be 10 or 15 years from now, and somebody comes across it and says, hey man, I'm going to replace it. So they'll cut all them new capacitors out and replace them when there was no need to. So make sure you leave a note. I don't like to do that. But so what I'm going to do here is I've took and got, you know, some of these. I got whole bunches of different ones of these terminal strips. I've got all kinds of them. And what I've done here, what I'm working on doing, is I drilled out this rivet and put a 440 bolt and nut on there with one of these, got it good and tight. And then I'm taking it off, like I've already cut this one off. I've completely, and I always make sure you cut it off flush, get it out of the way. Like I said, I leave the can there for looks. I can still use these ground tie points, but as far as, you know, going to the positive side of the capacitor, I don't use that at all. And I've heard people say, well, use it for a tie point. If the capacitor is bad, don't worry about it. Just stick the new one across it and go with it. But if this shorts out, which they will, and this goes shorted, then it's gonna, you know, what's the point, you know? So just cut those out of there. And so I'm moving all the wires, and I'm gonna do the same thing here. I'm gonna drill that out, push all this stuff out of the way, reroute it a little bit, and I'm working on this one now. I've already unsoldered it. You can see it's loose there, but and this here's got to go over to here, and then this goes to here. Yeah, I'll get to that in just a second. So that's what I'm going to do, and then take all these, at least put two of them over here and two of them over here. Now this has got 3 terminals on it, but this one just goes straight down to the ground here, so I can use that for a ground if I need it. And I'll probably use that for the capacitor, like one capacitor I can put here, and the other capacitor I can put right in here, like, let's see. Like I can set, you know, a capacitor here, like that. I can set a capacitor here like that, you know, in there, and tie it to that. Get where you can see it better. I can tie it to that, you know, of course that'd be ground. Put ground there and that. Probably tuck them in a little bit better here, and then put there'll be 2 on this side, one being a 10, because this can's got 2 10s and 2 20 microfarads. So I'll put 2 10s, which I have 10s, and then the 20s I use 22 microfarads, and that's fine to do that. That's not too far off, especially for a filter capacitor. So I'll do that. That way it'll be kind of neat in here. This can will still be up here for aesthetics and for looks, you know, for that old nostalgic look. But down here I'll have new capacitors. Now I was going to show you, I was talking about here, this is just temporarily tacked on here, and this ain't even tacked yet. These are these roundies I was talking about, and here's the other one. The other one's got to go from here down to this lug here. You probably can't back out just a little bit. You can see. Oh, come on. There's a hole there. I got to solder that. It's got a wire here going across. That's where it would go. This one will go to here, which would go here. See, this has been taken off. It went across here. If you remember in the rewind the video, you can see it was going across here. So now I'm going to take it across here. I got to take this loose and bring this over to here. It's probably going to be too short. Instead of trying to add a piece of wire or some kind of weird thing, I'll probably just save this and replace it. But that's just in there temporarily, because this one would go from here down to there. Of course, that obviously ain't going to reach, but I'm not going to use these anyway. And I just wanted to show you. These are supposed to be, that we can see, it's kind of hard to see, but it's gray, red, orange. Why is that blurry? There we go. Gray, red, orange. So 8, 2, and 3 zeros, A2K. That's what it's supposed to be. Let's look up here and see what it shows here. I'm going to be careful not to touch both sides of this thing here so I ain't interfering with it. Let's see. Why in the world is that doing that? That'll help. There we go. Okay, can you see that? Oh, there's kind of a glare on it, ain't there? I hope you can see that. Let me get my pointer here. This is supposed to be 82K. This 8, I've got it really zoomed in so you can't see it, but I've got it on the ×10 scale. So this 8 right up here would be 80K. This 10 would be 100K. That's just the needle's width off being 100K. If I put it on my LCR, it's showing 99K or 98.5K or something like that. It's real close to 100K. So I just wanted you to see, and that's what happens with these. That's what happens to these little roundies. How far can I get without still? Let me bring the camera back down here. Yeah, there we go. I'll move that around so you can kind of see. That's definitely, see, it's kind of rounded off there. At first glance, at a distance, you know, you might say, oh, that's one of them good ones, but if you you get it kind of trained out, you see this brown is a little bit tinged different brown than this, say this one down here. And this one down here, if you can see it, that's a real sharp cutoff, like somebody's taken, you know, something like this here and made a real nice, pretty straight, flat cut. So when you look at the end of it, it's flat. But this one, well, this little brush here, look at the end of this, see how it's, you can probably see how that's rounded off, just for comfort holding in your hand, I guess. But so that's rounded, it's kind of rounded like that. Whereas, well, I sure ain't got nothing, I wouldn't I'm prepared for this. But this is not really a good example, but you see how flat that is. It's chopped off flat. That's, you know, like the Allen Bradley style. But sometimes you can go through and you can check these, and this will all be pretty close and be fine. And then you can go through and check every one of them, and the circuit will be bad. This one's showing 99 point something K or whatever. And the one that's, I've still got tacked in circuit up there just so I don't forget what goes where. Of course, I took a lot of pictures, and I always advise you take a lot of pictures and restore and stuff. Nowadays, it's so easy, just grab your smartphone out and snap a bunch of pictures in different angles, so you don't go, oh crap, where did that go? Especially if you ain't got a schematic on something, you're having to reverse engineer it a little bit and restore something. But I've just got that tacked in there to keep up where I'm going, you know, which way it's got to go. I'm going to replace it with an Allen Bradley style. But I just want to kind of go over that with you and show you where I was at so far in the process. And I know usually I do this stuff and bam, ta-da, here it is. But like right now, this here, I've already got loose, so what I'm going to do is I'm going to take this. I don't know how good this camera angle is going to show. Not good, is it? I'm trying to save everything I can of that. Not cut it. Okay. See, that ain't going to reach. I haven't come close. You see that, but it's got to go here. Okay, so I've got to go in a drawer and get a 47K resistor, put across here, and go ahead and get these things out of here too. But I was just trying to get this all set up here with these terminal tie points. But then I'll go in here, work my way around different ways and whatever. But I'll cut these out. And sometimes it's aggravating to get it like I want it, so I can come in and cut it out. But that's what I'll do, is I'll go and just cut these off. I don't want this to interfere whatsoever. This old capacitor that's up in this can, to interfere whatsoever with it. I checked this one here before I cut it off, and wow, was it bad. It was showing almost 40 microfarad, and it's supposed to be, is that the one that's 10 or the one that's 20? So that's a D. See the bottom of these cans too, if you, first time you've come across these. Let me see if I can zoom in on that. See if you can, you should be able to see that. Yeah. There's a little, look like a symbol of a D. This here's got a dash, or a square. See that? And this over here is a triangle, and this here has nothing. Okay. If we go to the side of the can here, and I can get it where there's no glare. Let me Hard to see all of them because of the choke in the way there, but you see it shows the half moon, or the D shape. Comes across, it says that's 20 microfarad. I know that glare is a little aggravating, but 20 microfarad at 450 volts. Okay. Square, which is hard to see, for there you go, square, 20 microfarad, 450 volts. And it goes on down, so this triangle is 10 microfarad. And they show a little dash here, but it's not, it's just, dash means it's blank. Just a blank is this one here. It's another 10 microfarad. So that's where I'm at right now, what's going on with it. And I usually, you know, one reason kinda is, you know, I don't get into deep details of this, and you know, I kind of show you, well, here's this and blah 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 blah, it looks like this, and yep, this and that's got to go, and I'll be right back, and then I'll off camera replace everything and go through everything, and then come back and go ta-da, because it takes up so much time. And you know, I know some people was like, you know, when you upload a video that's an hour long, some people goes, ugh, and they kind of skip over it. You can let me know in the comments, you know, if you'd like longer or shorter videos, whatever. I know some guys really like it. They would love it to be 4 hours, every little detail, have 3 cameras or 4 cameras set up, and run every little angle and detail of everything. And some people just, hey man, just get to the point, so I ain't got to keep hitting fast forward or keep jumping through the video to get to the, just get to the point, man. What'd you do? You know, stuff like that. So anyway, there's where I'm at right now. So I got to finish this up, replace this, put another one of these in there. Of course, you know, replacing both of these. I'll have to get another one of those so it ain't some kind of weird extension thing going on. I mean, sometimes you might have to do something like that, some kind of odd part that you just can't get, but it's fine. You can take like a, this ain't a good example, but you know, take a clipping off of another part and take this part here and kind of twist them together. I've seen people just kind of tack them in there. You know, they'll, my fingers out of the way here, they'll just kind of stick it in like that, and they just tack it in there. Just kind of hold it and put a little solder on it, a little solder here, but it makes it so weak, you know. So kind of twist them together with another piece of wire and bring it over if you have to. If it's something that's going to have to be a long ways off, you may have to take you a terminal tie point like one of these here I've got, that's just a single, you know, bolts to the frame, and you got one tie point. You know, it's surely somewhere you can find somewhere, or sometimes you have to drill your hole, make you put your screw in to do something like that, so that way it's not weak like that. But, and I started to do that just to show it done like that, you know, pretend like this 47K resistor, man, they're so rare these days. But anyway, so there's where I'm at with that, where I'm at now. And I'll finish up this, and it seems like I'm having something else I'll tell you about. I'll think of it for the rest of the video. I'll get it finished up, and we'll I'll be back in a little bit, and we'll hook this thing up and see what it does.